Hello, statistics students. This is Mr. Gazzato, and we're going to go through different ways we describe shape of a graph, different measures of center that we know, and different measures of spread. So if you look at this histogram, how do you describe the shape of this histogram? So I'm going to ask the question, you can answer it, and then I'm going to display the answer as we go through this. So this histogram is approximately normal. How would you describe this data set? This data set is skewed right. So hopefully if I draw this line in there, you kind of see it's skewing to the right. How would you describe this data set? This data set is skewed left. So if I were to draw this shape in here, you can see it's skewing to the left. How would you describe this set? Uniform. So if it's straight across, approximately straight across, it's called uniform. So a uniform distribution is approximately straight across. So here's a summary of skewed right, skewed left, uniform, and approximately normal. So I want you to be able to look at these histograms and identify the shape. We also discussed this graph. So the vocabulary words surrounding this are gaps, outliers, clusters. So this that I just circled is a cluster. Here we have another cluster, and then the space in between that is called a gap. Some people call it bimodal because there are two peaks. Here's a stem plot. How would you describe the stem plot? So if you turn your head sideways, it looks approximately normal. Second stem plot, how would you describe this shape? If you turn your head sideways, it looks skewed right. So I'm going to draw that line again, skewing to the right. This stem and leaf plot, how would you describe this stem and leaf plot? That stem and leaf plot is skewed left. So I'll draw that, and again, you have to turn your head a little bit. So here's a summary. Symmetric data, we used approximately normal down at the bottom of the screen. Skewed right, skewed left. Dot plots. How would you describe each of these dot plots? Go ahead and take a minute to answer the question. So top left, skewed right. The top right picture is skewed left, and the bottom picture is approximately normal. So that summarizes shape. The second thing I want to talk about in this video is center. So we've been studying median and mean. So you should be able to calculate the mean and median using your graphing calculator using one variable stats. You should also know the mode is the number that occurs most frequently, but that is not an emphasis for this class. So I want to compare and contrast here. If you look at the histogram, you see it's approximately normal. Hopefully you see the box plot here. Both boxes are about the same. Both whiskers are roughly the same. You do have an outlier that I just put the arrow. But the idea that I'm trying to get to is if you look at the mean and the median, so the top number is the mean, the bottom number is the median, you should notice that they are approximately the same. So the main idea here is in approximately normal data, the mean and median are about the same. Let's take a look at some skewed data. This data is skewed to the right, and when it's skewing to the right, I'm hoping that you see we have a long whisker, a longer box, a shorter box, and a short whisker. And if you look at the data, the mean and the median, you hopefully realize that the mean is much bigger than the median. That's because these numbers that I'm just circling here are going to pull up the mean. So the mean is bigger than the median. Let's look at skewed left data. On skewed left data, again, a longer whisker on the left, a longer box, a shorter whisker. If you were to look at the data, here the mean is 19.618. The median is 19.685. There's a small difference here, but we're talking about seconds. So because the unit is so small in seconds, we can tell that the mean is smaller than the median here. And in skewed left data, I want you to know that the mean is smaller than the median. So here's a little summary. Which measure of center would be better? On skewed data, we always want to typically use the median because these large numbers or these small numbers pull the mean towards them. If you have uniform data or approximately normal data, we typically use the mean. It's a better measure of center, though the median does work. Okay, a vocabulary word, mean versus median. You could read this paragraph. Actually, I'll read it to you because I think it's important. Because the median considers only the order of values, it is called resistant to values that are extraordinarily large or small. So if there are outliers, the median is a better measure of center. Second bullet, to choose between the mean and median, start by looking at the data. If the histogram is symmetric, approximately normal, and no outliers, use the mean. Third bullet, however, if the histogram is skewed or has outliers, you're better off using the median. So the goal of these last couple slides was to review the concept of mean and median and which is a better measure of center. All right, last thing I want to talk about in this video is measures of spread. We studied 3 of them: range, interquartile range, and standard deviation. The range is defined to be the maximum minus the minimum. The interquartile range is defined to be Q3 minus Q1, and it represents the middle 50% of the data. And in both skewed data and data with outliers, the interquartile range is a better measure of spread than the standard deviation. The reason we want to use the interquartile range when you have skewed data or outliers is because the standard deviation is the typical distance from the mean. So if you have outliers or skewed data, the standard deviation is pulled towards the outliers or towards the skewed side of the graph. So what's a better measure of center? This is just a review. On skewed data, which is on the left side of the screen, the median is better. On the right side of the screen, if you have uniform or approximately normal, both the mean and median are appropriate, but we typically use the mean. Remember, the median is resistant to skewed data and outliers. So when we move to measures of center, the same theory applies. If you have skewed data, you want to use the interquartile range. I'm putting an arrow there. If you have approximately normal or uniform data, you want to use the standard deviation typically as a measure of spread. So the interquartile range does work on uniform and approximately normal data. But as we'll learn later on, statistics often uses the standard deviation and mean more than the median. So just a quick little summary. First bullet, because the IQR is related to the median, considers only order of values, it is resistant to values that are extraordinarily large or small. It simply notes that they are that's a little phrase, awkwardly. So the main idea is the IQR, I'm going to circle it, I'm just going to paraphrase, is resistant to outliers. Second bullet, to choose between the IQR and standard deviation, start by looking at the data. If the histogram is symmetric and there are no outliers, use the standard deviation. Now instead of symmetric, we've been using approximately normal. Third bullet, however, if the histogram is skewed or has outliers, you're better off using the IQR. So that was a summary of shape, center, and spread.